Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's program is Search for Life in the Solar System and Beyond. With us to talk about this topic is our own Dr. Timothy Day. He's a member of the AFE team and also a member of the Ford Amateur Astronomy Club. Dr. Timothy, welcome to the program.
Well, thank you. It's very good to be back and to be visiting this topic once again.
We did this program in two parts about 4 years ago, but we have new information?
I would have been surprised had you told me then that we would be revisiting this with all this new information so quickly, meaning only 4 years. But a lot of things have changed, and there's a lot of new exciting information coming in about places where we can look, and we may very well possibly find life, at least simple life, within our own solar system. And then the game is afoot outside of our solar system. We now have a list of thousands of exoplanets that we are aware of, and we're beginning to scrutinize those for signs of life as well.
And that part we'll cover in the second half of this presentation. But for now, we're going to start within our solar system, starting with the terrestrial planets.
We'll start on the inside first, same as the last show. And I'll work my way from Mercury, closest to the sun, and we'll take our way all the way out to Pluto and its moon Charon, and then maybe a little bit beyond, as you mentioned, towards the end of the show.
Great. So start us off. We're looking for water?
We are always looking for water when we're looking for life. Water is the universal solvent. It's a polar molecule. That's a fancy way of saying it's got a plus pole and a minus pole, and it does a fine job of dissolving all sorts of other things. Not everything, not plastics or metals usually, but certainly organic molecules do very well in water. And we're looking in particular for liquid water. So steam tends to be too hot for molecules to hold together well. Frozen water, not moving much, so things don't swim around in that. So liquid water is the key. We get real excited when we think about the possibility of liquid water.
So we're going to begin with Mercury?
We're going to begin with Mercury. Let's have a picture of that up. And there it is. This is false color, so there's been a little bit of blue added, but some of the blue is actually close to natural as well. And as you can see, this thing is covered in craters. It's an old surface. And when we say old, it's not that it's older than any other surface of anything else in our solar system. It's just never been resurfaced. So it's been hit over and over and over with craters and meteorites and strikes, and you can see all of these craters, and they're still standing. You can see the history of Mercury going all the way back to probably about the time of its formation. And it's dry. It's close to the sun. It's hot on the side that's facing the sun. There is a cooler side. It does rotate. It's not tidally locked permanently. There's actually a little bit of ice that they can find with a radar that apparently comes and it goes, but there's no atmosphere. There's no liquid water. It's pretty to look at in this picture, but we don't get very excited when we think about life on Mercury. So just like the first show, we're going to give Mercury a hi, you're very pretty, and a pass.
So we'll move on.
We'll move on. The next one, of course, is Venus. And Venus has got a pretty blue atmosphere. We also look for water there. And this is actually an image of Venus taken with a radar. So an American probe, a U.S. probe, went there a couple decades ago. And this is a atmosphere penetrating radar. And it looks red and hot and volcanic and just nasty. And it is. There's no liquid water. There's only a temperature of maybe 700 degrees or so, hot enough to melt lead. There's a nice picture of what Venus looks like a little more naturally. And you can see it's a crescent. When we look at it from our telescopes from Earth, it's a nice crescent photo, or nice image.
Sure.
So it's real pretty, but again, no liquid water, hot, it rains sulfuric acid. When I was young, people got excited about Venus being Earth's twin. It's the right size. It's got a nice big atmosphere.
But that's about it.
But that's about it.
Mm-hmm.
So pretty in the night sky, but not very promising in our hunt for life. So we'll give this one a pass as well.
Where to next?
Next, let's go to our own moon. Oh, here's a picture of Venus again with the image taken from radar, and you can see all of the volcanoes, the surface features. And then we have one more image of Venus. The Russians, the Soviets at the time, were very, very tenacious in sending probe after probe after probe to Venus. The first ones actually had pontoons on them. They expected to land in water possibly, and they needed to float. Surprise! Everything they dropped in there just burned up, and they just kept making them tougher and tougher. The name of the series was Venera, which is the Russian for Venus related, and they went up to, I think, 16, 17 probes over the course of a couple decades.
That many altogether?
That many. This is number 13, and it shot off a couple of images and got them back up and out before the whole thing just melted and collapsed. You can see those spiked feet there. And
exactly.
Yeah, no liquid water there, but it's a really cool picture to see.
It is.
Yeah. So our next one is, let's look at Earth's moon next. And that's something that is real familiar to everybody. And this is the iconic picture. That's actually Buzz Aldrin. And the photographer was Neil Armstrong, so it's Apollo 11.
Yep.
And they set this up on purpose very carefully. So if you look in Buzz's face mask, you can see Neil in the background taking the picture. It's almost like a mirror image, and then the lander that they came down in. But the part I want you to look at is all around Buzz. It's craters again. It's like Mercury. The history of what's hit this moon is still there for us to study and look at. And you've got billions of years of activity. It used to be warmer. There used to be pools of lava that would maybe come up and create the Maria, what the Galileo thought with the seas, the smooth areas, right, that are darker. But the moon has long since cooled off. There is no perceptible atmosphere or significant atmosphere, and there's certainly no liquid water.
They have found some ice in some of the craters in the South
Pole.
Pole.
They have, and we're trying to figure out whether or not that's substantial ice and whether it can be utilized. They were concerned about the possibility of the first astronauts bringing back moon bugs that we would have no resistance to. And so the first Apollo missions, 11 and 12 and 14, they would put those astronauts, here's a good shot of the Apollo 11 crew, with Richard Nixon, the president at the time, looking in, and everybody's got big smiles on, but those guys had to hang out in that trailer for about 2 weeks until the doctors gave them an all clear and made sure there weren't any lunar superbugs that were going to take over our planet, you know. And after about 3 missions, they said, you know what? No life on the moon. We're going to stop torturing these guys by putting them in these airstreams for 2 weeks and making them hang until the doctors wave a green flag and say it's
good
all
idea. Good idea.
So that takes us through our moon, and we haven't found any liquid water yet.
Yeah.
Okay. So now our planet, Earth.
Yes.
It's an ocean planet. About 3/4 ocean by surface area. And what we discovered during the 1970s, we had no clue about this until we were able to build submersibles that were strong enough to withstand the amazingly crushing pressures at depth in the ocean, 1 mile, 2 miles, 3 miles. You can go all the way to 7 miles in the Challenger Deep off the coast of Japan. And it becomes equivalent to like tons of stacked elephants or 747s per square inch of pressure. Right. So there was no way to study what was down there in any significant way. This is something called the Johnson Sea Link. It was one of the early pioneers. You can see a big acrylic bubble in the front, and there's a room for people to be in there and pictures to be taken. And it went down about 1.5 miles and discovered something called black smokers. And these are these vents where the ocean's crust is thin, and this is literally volcanism. This is the same thing we would see as volcanoes, say in Hawaii or in Iceland, but now we're a couple miles into the ocean. And this water is so hot that if it was outside of the ocean in our atmosphere, it would flash instantly into steam. But because of the tremendous pressures, it stays liquid, comes out under huge force. And it's laced with all of this nasty chemical stuff.
That's what gives it the color, so to speak, not
Exactly.
being transparent.
Yep.
Right.
So black smokers was the nickname the scientists gave them, and it's hydrogen sulfide. It smells terrible, but more than that, it's a nasty poison to terrestrial organisms, plants, animals, you, me. So you would figure this would, between the hot water and the chemical constituency, kill everything. But here's what's covering it. They were astounded. There are tube worms, there are clams, there are crabs that live on that. There's a whole chain of life that starts with special bacteria that can take that hydrogen sulfide and convert it into other chemicals, and then there are organisms that feed on the bacteria and bigger organisms that feed on those organisms, and a whole
food chain.
the whole food chain minus the sun, which was astounding to biologists, because up till that point it was assumed that all life on Earth is dependent on light from the sun. Green plants, cows eat the plants, carnivores eat the cows, and so it goes.
Carbon dioxide into oxygen.
Carbon dioxide into
yeah.
oxygen, the whole thing. This is life that could exist if the sun winked out. As long as the Earth stayed warm and kept doing this and the oceans stayed liquid, this life would persist. It is not solar-based. So the part that gets exciting for our search for life in the solar system is we now begin to imagine, what if there were other places in the solar system with similar hydrothermal deeps and all this sort of thing, and could there be bacteria there and life that feeds on the bacteria and so on and so forth? If we go to the next slide, you'll see that life is amazing. This is actually a firefly. I included it because there are fish that do the same thing. You see the two bottom parts there are glowing as the firefly winks. Bioluminescence. So this creature makes its own light. Creatures in the deeps around these seeps, a couple miles down, fish, they do the same thing. They can create their own light, and they can backshadow themselves and make themselves difficult to see, or they can light the surrounding area up. It's really pretty amazing. If we go to the next slide, this is a real fish. It exists down there. It's technically called a sculpin, S-C-U-L-P-I-N. I'd never heard of it before I saw this photo, but it's a sculpin fish. This one's got a nickname. His name is Mr. Blobby. He's from New Zealand. But this is, I mean, if you want to talk about weird,
Yeah.
could you imagine finding this on, another moon or a planet or somebody else's ocean, not our own? How much more exotic do you want to get? I mean, this is really fun to look at.
I have never seen anything like this before.
I hadn't before this picture either.
No.
The next one I have here is a squid. Here's something that also exists at these depths. Now, instead of it lighting up like the firefly or the fish that are bioluminescent, it's got a huge eye. And that's the approach a lot of critters around these seeps take. They get great big eyes, and they want to collect every last photon of light because it might mean a food source or a danger source they need to get away from. And then finally, I included one more that's just so strange. You could imagine this in an ocean on Europa or Enceladus. This is called a gulper eel. It's kind of hard to tell it's an eel, right?
Right.
The tail part of the eel hangs almost vertically. It's the part curving off to the left. The mouth, the gulper part, opens up so wide that it can actually swallow other critters much bigger than itself. And that's because meals can be so rare at the depths. But I included it just because how strange do you want to imagine life getting?
Exactly.
And this is just our own planet, right? So the possibilities are exciting.
Yes.
It's fun to think about.
It is. Truly amazing.
All right. So that's an example of life and black smokers and some of the concepts that we're looking for on other planets here on our own first. And next I want to take us out to Mars. There's a lot of excitement about the possibility of life on Mars. There has been for a while. Mars is smaller than the Earth. It's farther away from the sun, and it cooled off faster than the Earth has,
Being
or Venus.
smaller, less mass.
Being smaller, less mass.
Sure.
And as it cooled, it lost its magnetic field, and with the magnetic field going, the solar wind from the sun blew away its atmosphere. It still got some.
Yeah, it's
But 1% of ours, thin. You wouldn't be able to breathe it.
thinner than the top of Mount Everest?
Thinner than the top of Mount Everest by far, and all CO2. So that's no fun.
No.
Okay, but the atmosphere is sufficient to keep water that might be in ice form in a liquid state from time to time. And it's very likely from looking at Mars. Here's an image of Horowitz crater on Mars. And you'll see two little arrows towards the upper right where it says 20 meters. That's what
Yes.
the M stands for. There's little streaks, they're tan, if you can say. Those come and go every year. And what we're pretty sure that signifies is liquid water that's a couple of centimeters underneath the crust of the Martian soil, and it goes forward and then it retreats with the changes in temperature. Mars has a north and a south pole like we do.
And their axis is tilted, so they have seasons.
And they have seasons, and we know that there's CO2 ice that sublimates into gas and then refreezes. And we know that there is almost certainly water ice that becomes liquid and it runs, goes downhill just like water does here, and then it freezes up again. And so we keep going to Mars because there's good reason to keep going to Mars. We may actually see life still existing. That would be the most exciting. That's what Carl Sagan was hoping for back in the Viking landers in 1976. We've continued to send rovers. The most recent, the biggest one was Curiosity. It's like a big golf cart. The next one coming up is Mars 2020 rover. You can see a diagram of it here. And this is going to be like the Curiosity rover on steroids. It's got something like 58 different instruments, and it will be able to do everything Curiosity did, only bigger and badder and better and longer. And we're really hoping to go to all the places the other rovers have shown us to be of interest, places where water might still be running up, down, whatever, turn over rocks, zap things with lasers, look at the light that comes off. Was this an organic molecule once? Mars is worth continuing to pursue. We haven't found it yet, but that doesn't mean we won't.
And we'll keep looking.
So we're going to keep looking.
It's a great place to take a break in our discussion. If you have a question, please send us an email. As always, we'll have the email down there at the bottom of your screen. We like to receive those, of course. And coming up next is Term of the Month. Stephen?
Thanks, Don. The term of the month is Lagrange points. Lagrange points are mathematical points of semi-stability or real stability. They were invented by mathematician Lagrange, and there are 5 of them. So you have 2 massive objects. One is much more massive than the other. So in this case, we have the Sun and the Earth. So the Lagrange point number 1 is between the Sun and the Earth, and it's about 1 million miles from Earth, so 93 million miles to the Sun. So it's mostly close to the Earth. And it's great for having a satellite, having a mission that can look at the Sun 24/7. It absolutely can look at the Sun all the time. And it's close to the Earth for communication. 2 is on the other side of the Earth from the Sun, and it's great for looking at the rest of the universe, and it's still pretty close to the Earth. 3 is on the other side of the Sun. It's not very good for communication. It's not very stable for various reasons, and it's not terribly useful for much of anything. Looking at the backside of the Sun, maybe. 4 and 5 have been proposed as colony spots for a big space station where people would live, but we're not there yet. Anyway, the term of the month is Lagrange points. Back to you, Don.
Thanks, Stephen. We're back with Dr. Timothy Day talking about the search for life in our solar system and beyond. So now we're past the rocky planets and up to the gas giants.
We are, and things get exciting. Let's go to Jupiter, and in particular, one of the 4 main moons of Jupiter called Europa. And we like Europa. Here's a picture of Jupiter, and that's a real image of Europa. And along the bottom at the South Pole, you can see that blue flame. It almost looks like a gas flame.
Yes.
That's a geyser. That's saltwater ice. Here's an artist's rendition of what that might look like if you were standing there. And there is almost certainly a deep, deep ocean, more salt water than on all of Earth, on Europa underneath a couple miles of ice that keeps it from evaporating. Here's a picture of Europa's surface, and you can see the cracks in the ice.
Yes.
And so this is not a surface that's full of craters, with maybe one exception. There's a crater quill that we can see, but the rest of it is all brand new material. And it cracks and it forms and geysers come out. So we are sending a probe there. It's going to be called the Europa Clipper. Here, there's the crater on the bottom right-hand side, but this is, you can see that this is a moon.
It looks like a cue ball.
It's like a cue ball. It's smooth. It's a fresh surface. Ice is continually coming up and falling back down again. No craters to be seen with an occasional exception. We're going to send a clip. This is the Europa Clipper. It's an artist's conception. It's going to go out there. It would be nice to land on Europa and drill through the ice and go swimming in the water. That's a hard thing to do. Maybe the next generation can do it. So we're going to send a spacecraft that's going to fly through the plumes and taste the water and look for organic molecules. Very exciting stuff.
So
that's coming up in the 2020s, mid to late 2020s.
Great. So what have we got with Saturn?
Saturn has a couple of exciting moons. One of them is one of the biggest moons in the solar system. It's Titan, and Titan has an atmosphere. You can sort of see it in this image, the blue around the edge. And so we went ahead and already sent one probe there. It was
the
called
Huygens probe.
The Huygens probe, that's right, part of the Cassini mission. And this is an actual photo from the Huygens probe. And Titan has weather. Titan has methane seas. It's cold, but there's liquid hydrocarbon and solid hydrocarbon. It's worth exploring, and so we're going to explore. They're going to send an actual quadricopter, or actually 8 blades. I'm not sure what you would call that, a hexacopter, and it will be able to be flown remote control with a parent probe from Mission Control, and they'll hop it around on Titan looking for interesting places.
Wow.
There's a second moon around Titan. It's smaller than Europa. It's called Enceladus, and here, once again, you see water geysers.
The geysers, yeah.
The geysers and an icy surface. So we're going to keep that in mind as well as a site where there may well be deep oceans. Here's the surface of, it's a cue ball, right? No craters. It's just smooth as can be. That's a sign of a very geologically active moon. And here's, you can see small craters there, cracks in the ice. We'll be going to Enceladus. It's an exciting place.
What about Uranus and Neptune? Anything going on there?
Uranus is pretty. It's a sea foam green in a telescope. It's a giant ball of hydrogen and helium, and there's almost no chance of liquid water there, so we're going to give it a pass like we did the last show.
And Neptune as
And
well?
here's Neptune, same deal, farther away. You can see its moon Triton, excuse me, in the lower corner. Triton is one of the coldest places in the solar system, about 4 degrees above absolute zero. Not much liquid water there. We're going to give this one a pass too. Very pretty, not much chance of life there.
So that leaves us next with Pluto.
Oh, and Pluto is on my list, not because there's liquid water there that we're aware of, but simply because things happen on Pluto's surface. Things change. There's different colors. There's different shapes. If you look at the next slide, that's even closer in, there's texture to the surface of Pluto. Nobody would have guessed that. And so I include it just to say, let's not close any doors prematurely. Let's keep looking at everything and just see what surprises pop up.
Exactly. So what about exoplanets?
For that, we need big eyes. People think about the Hubble Space Telescope, which is on the left. There's a bigger one coming up in just a couple years called the James Webb. I think 2021 it launches.
Yes, I believe.
And it sees in the infrared and it sees far away. And if we go to the next slide, this is an artist's illustration of a planet that's really been discovered. It's exoplanet. That's what we call a planet not in our solar system. K2-18b, not a very romantic name. But it's exciting because for the first time we have absolutely identified water vapor in another planet's atmosphere. And we do that by looking at the light from its own sun, which is a dim red dwarf. It doesn't overwhelm the planet. And if we go to the next slide, there's a picture of a prism, and I just want you to, white light goes through the prism. Everybody's familiar with this, red, orange, yellow, green, blue, indigo, violet. Here's another nice prism image, what happens to the light. So what happens is if there are molecules in there, they will actually show up as dark lines called absorption spectrum. And here's a nice image of an absorption spectrum. And that tells you water vapor is here. There on the bottom is another absorption spectrum. And so we know that there's water vapor in another planet outside our solar system. That might mean life. It's exciting. It's good times for looking for life.
It sure is, and I'm glad we were able to get you back in the studio to bring us up to date on all of this new and exciting information. I want to thank our guest, Dr. Timothy Day, and please visit our club website. We always like to have you check in there as well. And coming up next is Stephen with What's Up.
Thanks, Don. What's up in the night sky for February 2020? The sun rises at 7:47 a.m. to 5:47 a.m. over the course of the month. Astronomical night starts an hour and 36 minutes after sunset and ends an hour and 37 minutes before sunrise. The moons, which we have here still, February starts with a first quarter moon. And then we have the full moon on the 9th. We have a third quarter moon on the 15th. And finally, no picture for the new moon on February 23rd. The morning planets. We have Saturn, Pluto, Jupiter, Mars. All of these red lines are orbits, not only of the planets, there would be far fewer of them, but also of their moons, especially for Saturn and Jupiter, there are a zillion of them. Saturn rises at 6:50 to 5:21 over the course of the month. That's AM. Pluto is very similar, rises from 6:55 to 5:12 over the course of the month. I really doubt you'll be seeing it. Jupiter it rises at 6:16 to 4:51 over the course of the month. And finally, Mars rises at 4:33 a.m. to 4:10 a.m. over the course of the month. All of these objects are in Sagittarius except Mars, which is in Ophiuchus. Not shown is Mercury, which is in Aquarius. It has an inferior conjunction, that is, it goes across, not across the face of the sun, but it goes right by the sun on the 25th. It's going to be extremely difficult to spot. I don't recommend it. The evening planets, Neptune, Venus, Uranus, the moon, and bonus points for Vesta. So Neptune is in Aquarius, where it always is. Uranus is in Aries, where you might think that Mars would be, because Aries is. Venus is in Aquarius along with Neptune. So Neptune sets 8:37 to 6:55. It's really quite close to the sun. Venus is much brighter, so you might spot it anyway. 9:08 to 10:05. It gets higher later. It's interesting. Venus does that. Uranus, 36 minutes after midnight to 10 p.m. And that is what's up in the night sky for February 2020. We don't charge for this show, but we may tax your brain.